We are given two vector valued function of t and s of t, and we need to find the value of the integral going from 0 to 2 of the dot product between r and s with respect to t, and the value of the definite integral going from 0 to 2, the cross product between r and s with respect to t. So let's begin. So what we'll do, we will obtain the dot product or the scalar product between vector r and vector s initially. That means for vector r we have t I cap minus t squared j cap plus t minus 1 k cap. So this will be dotted to the vector s, which is 2t squared I cap plus 0 times j cap, because we do not have the y component here, plus 6t times k cap. To find out the dot product, all we have to do is multiply the component of I cap or both of the two I cap together. So here we have t multiplied to 2t squared, so that will be simply 2 times t cubed. Then we'll take the y component of vector r and multiply it to the y component of vector s. Since there is no y component of vector s, so that will be simply 0. Plus we'll take the z component of vector r, which is t minus 1, and we multiply it to the z component of vector s. So let's do the multiplication. So t minus 1 multiplied to 6t, that will be 6t squared minus 6t. Right. And here we have used the fact that I cap dotted with I cap, so that's equals to 1. Same goes for j cap dotted to j cap and k cap dotted to k cap. And since they're orthogonal vectors, so we have I cap dot j cap equals to j cap dot k cap equals to k cap dot I cap. All of these values are going to be equals to 0. That means we have finally, so we have 2t cubed plus 6t squared minus 6t. So this is the dot product between vector r and s. Let's label this as equation number 1. We'll use it later on to find out the value of the definite integral. Now what we'll do, we'll take the cross product between vector r and vector s. For this, let's use a 3 by 3 determinant. In the first row, we have the unit vectors I cap, j cap, and k cap. And in the second row, we'll have components of vector r. So vector r have the components t, negative t squared, and t minus 1. Well, in the third row, we'll have components of vector s. So that will be 2t squared, 0, and 6t. Let's expand this along the first row. So we will get I cap. So this will be multiplied to, so we have negative t squared times 6t. So that will give us negative 6t cubed. Minus 0 times t minus 1. So that will be 0. So this is our x component. Minus j cap. We'll take the product between t and 6t. So that's 6t squared. Minus the product between 2t squared and t minus 1. That will be 2t cubed. We have negative 2t squared. So since there's a negative sign here, we'll be cutting to positive 2t squared. Plus k cap. So k cap will be, we have t times 0. So that's 0. Minus negative t squared times 2t squared. So we'll get positive 2t raised to the power of 4. So let's arrange this. So this is going to give us r vector crossed with vector s. So this will give us negative 6t cubed. I cap. So 6t squared and 2t squared. So that will become positive. So let's take it as negative times 8t squared minus 2t cubed. J cap plus 2t raised to the power of 4 k cap. So we have obtained the dot product between vector r and s and the cross product between r and s. What we'll do, we'll integrate each of them, each of 1 and 2, with respect to t, with the limits going from 0 to 2. So let's do that. So we'll integrate from 0 to 2, vector r dotted with vector s with dt. So this will be simply equals to integration going from 0 to 2. We have 2t cubed plus 6t squared minus 6t integrated with respect to t. Now this is simply equals to 2 times integral t cubed dt plus 6 times integral t squared dt minus 6 times integration t dt. All we've done is separated the integrals, so we'll integrate each of them. The limits going from 0 to 2. So let's do that. So this will be equals to 2 times the integration of t raised to the power of 4 is 1/4 times t raised to the power of 4, 0 to 2, plus 6 times integration of t squared will be 1/3 t cubed with limits going from 0 to 2 minus 6 times integration half over t squared with limits going from 0 to 2, which is simply half. We have t raised to the power of 4, so the upper limit is 2. We'll get 2 raised to the power of 4, which is 16, minus the lower limit, which is 0. Plus we have 6 over 3, so that's 2. We have t cubed, so using the upper limit, we have 2 raised to the power of 3, which is 8, minus the lower limit, 0 cubed, so that will be 0. Minus 6 over 2 will be 3. So we have t squared, so that will be 4 minus 0. And this will be giving us, we have half of 16, so that's 8, plus 2 times 8, so that's 16, minus 3 times 4, so that's 12. So this will be equals to 8 plus 16 minus 12, so that's 4. So we have 8 plus 4, so that's equals to 12. That means the value of the integral of the dot product between r and s with respect to t, so that will be equals to 12. Now let's do the next integral. So we'll take the integral going from 0 to 2 of the cross product between vector r and s with respect to t. So that simply equals to integration going from 0 to t 2. We have negative 6 t cubed I cap minus 8 t squared minus 2t cubed j cap plus 2t raised to the power of 4 k cap integrated with respect to t. So what we'll do, we'll integrate term by term, and we are going to integrate each of the components of the vector. That means we'll first take the integral. We have negative 6 times integration of t cubed, limits going from 0 to t with respect to t. So this is going to be the x component, so we'll multiply it with I cap. Next we'll have negative 8 times integration of t squared dt minus 2 times integration of t cubed dt. So this will be integrated from 0 to 2 for both the cases, and this is going to be the y component. So that means we'll multiply with j cap. And finally we have integration. We have 2 times integration of t raised to the power of 4 dt. Limits going from 0 to 2, and this is going to be a z component, so we'll multiply it to k cap. So let's perform the integration. This is gonna give us negative 6. So we have integration of t cubed, so that will be 1/4 of t raised to the power of 4 with the limits going from 0 to 2. So this is the x component, so we'll multiply it to I cap minus we have 8 over 3 times t cubed minus 2 over 4 times t raised to the power of 4, 0 to 2, j cap plus 2/5 times t raised to the power of 4 with the limits going from 0 to 2. So this is going to be k cap. Let's find out the value. So that will be negative 3 over 2. So we have t raised to the power of 4, so that's 16 minus the lower limit, which is 0. I cap minus, we'll use the upper limit. So we had 8 over 3 times 2 cubed, so that's 2 raised to the power of 3 is 8, so we have 8 times 8, 64, so we have 64 over 3 minus, so 2 over 4, that's simply 1/2. So half times 2 raised to the power of 4, so that's 2 cubed, so that means we have 8. And the lower limit is going to be 0. This is j cap plus 2/5 of 2 raised to the power of 5, so that's 32. So we have 32 minus 0 k cap. So let's combine this, and this is going to give us, we have negative 3 over 2 times 16, so that means 2 times 8 is 16, so we have 8 times negative 3, so that's negative 24 I cap minus 64 over 3 minus 8, so that's going to be 40 over 3 j cap, and this is going to be 2 times 32 is 64, so we have 64 over 5 k cap. So this is the value of the integral going from 0 to 2 of r vector crossed with s vector integrated with respect to t. So this is since we have taken the integration of a cross product, so we have obtained a result in terms of a vector, and in the previous case we took the integration of a scalar product between vector r and s. Since it's a scalar product, so that means our integral should also be in terms of a scalar value, which is 12. So let's write it down here. So we have integration going from 0 to 2 vector r dotted with s, which is a scalar product between the two vectors, integrated with respect to t gives us the value 12.